For centuries, national wealth was measured in gold bars or oil barrels sitting in vaults. Today, that metric has shifted fundamentally. The most valuable asset a state can possess is not precious metal. It is a cluster of used graphics processing units running the artificial intelligence models that drive autonomous warfare systems and intelligence dominance. While market prices for these chips fluctuate wildly based on consumer demand or crypto cycles, their geopolitical value remains absolute. States are no longer buying computer parts. They are acquiring sovereign capability to ensure survival in a digital age where strategic parity depends entirely on who controls the compute infrastructure required for modern decision-making speed. The question driving global strategy today is not about market efficiency but about functional utility during rupture. When export bans tighten or supply chains fracture, nations will pay any premium to bypass sanctions because losing access to this hardware means ceding critical advantages in conflict that has already gone digital. The chaos seen in pricing for used GPU clusters is not a sign of market failure. It is the feature of states competing to secure their equivalent of nuclear deterrence. Just as oil was essential for tank movement in 1940, compute power is now the fuel for military simulations and cyber defense. To understand why this specific technology has superseded traditional reserves, we must look at how nations historically managed strategic inputs during times of peace versus war. History demonstrates a recurring pattern where states hoard critical resources to survive conflict, only to dismantle those stockpiles once threats recede, leaving them vulnerable when the next crisis arrives. The United States maintained extensive rare earth and mineral stockpiles from 1939 through the end of the Cold War in the early 1980s based on a belief that global trade stability would prevent scarcity. However, as geopolitical tensions cooled, this episodic crisis response led to liquidation of these reserves under optimistic assumptions about free markets. The result was a dependency on adversaries for critical inputs when conflict returned unexpectedly, forcing nations to scramble during the very moment they needed security most. This historical failure is now being applied directly to compute power and semiconductor supply chains. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The modern vulnerability mirrors this past dynamic but with higher stakes due to the concentration of manufacturing capacity in specific geopolitical regions. China currently controls approximately 90% of global rare earth processing capacity, which serves as the essential raw material for the magnets used in precision-guided munitions, stealth systems, and the AI training models required to power unmanned swarms. This dominance creates a structural chokehold where access can be weaponized by restricting exports of materials like gallium, germanium, and antimony that are indispensable for semiconductor production. When a nation relies on another state for 90% of its refining capacity, it is not engaging in trade. It is operating under the threat of immediate strategic paralysis if relations deteriorate. Recognizing that market mechanisms fail catastrophically during geopolitical rupture, policymakers have moved beyond simple stockpiling to create more robust insurance models against supply chain weaponization. In February 2026, the United States launched Project Vault, a $10 billion public-private partnership designed to establish a strategic reserve for 60 critical minerals essential for GPU and chip manufacturing. Unlike traditional taxpayer-funded stockpiles that sit idle during peacetime, this model requires manufacturers to pre-fund access through commitment fees, treating supply security as an insurance policy rather than a volatile market commodity stored at Federal Reserve facilities. This shift acknowledges that waiting until a crisis hits is too late. The infrastructure must be secured and ready for immediate deployment before tensions escalate into open conflict. In the context of these strategic reserves, the condition or age of a GPU cluster becomes secondary to its raw compute throughput. A used cluster capable of running legacy but effective artificial intelligence models for logistics prediction or simulation training holds higher strategic value than new consumer-grade hardware because it represents immediate deployable capacity when supply chains are blocked by sanctions. The market price may suggest these chips are obsolete commodities with diminishing returns, yet from a national security perspective, their ability to process data faster than an adversary can react is the deciding factor in modern warfare scenarios. This explains why states will bypass export bans to acquire seemingly expensive computer parts. They are not buying hardware for profit, but securing the physical infrastructure required for national survival when digital dominance determines victory or defeat. The stakes of this competition extend far beyond economic metrics into the realm of military readiness and intelligence superiority. If a state cannot guarantee access to high-performance compute during a crisis, its autonomous systems may fail, its cyber defenses could be overwhelmed, and its ability to simulate battlefield outcomes would vanish. This creates a scenario where the winner is determined not by who produces the most chips in peacetime, but by who controls the physical infrastructure required for decision-making speed when time runs out. The shift from viewing GPUs as consumer electronics to treating them as critical national security infrastructure marks a fundamental change in how states assess their own vulnerabilities and those of potential adversaries. The convergence of historical lessons, supply chain concentration, and new reserve mechanisms creates a complex landscape where the value of technology is defined by its utility under duress rather than market price volatility. States are now willing to absorb significant costs and bypass international norms because losing access to this compute infrastructure means ceding strategic parity in a conflict that is already digital. The logic driving these actions is clear. Just as oil was essential for tank movement, compute power is the fuel for modern military decision-making and autonomous operations. For curious observers of world events, understanding this dynamic reveals that global tech trade wars are not about protecting jobs or stopping inflation, but securing the physical foundation required to survive in a future where information processing speed dictates national survival. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.